The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to our today's webinar about the application of CFD simulation for HVAC system and HVAC ducting systems. And today we have a special guest and we are going to talk about how cloud-based tools will bring the AEC industry together. And I'm very happy that today with me is Steve Holzer. Steve is a product evangelist at BIMobject, one of the leading companies in the field of cloud-based technologies for the AC industry. And I don't want to talk too much about BIMobject, and Steve is here and he will talk about it shortly, but this will be really thrilling. And as I mentioned, our focus today is to show how we can use together both tools, BIMobject and SimScale, to shorten design processes for building projects. My name is Milad. I'm the product marketing manager here at SimScale, and I'm organizing and hosting on a regular basis workshops and webinars which introduce new and existing users to different aspects of engineering simulation and cloud-based product design. All right, before we get started, let's take a quick look at our today's agenda. As I mentioned, Steve will start and introduce you to BIMobject. So he will talk about the company and also about their cloud-based platform or cloud-based database of for information and CAD data. After that, we will quickly talk about the benefits of simulation and how simulation can be used in the building industry. And followed by that, we have prepared a short live demo where we will import the model of a ducting system from BIMobject, load it to SimScale, create a simulation, and take a look at the simulation results in order to understand how CFD simulation of, let's say, existing data can help to get a better idea and understanding of the performance of building equipment inside the project. Well, and now I would like to give the stage to Steve. 1 second.
Unmuted.
Steve, can you hear us?
Yes, good afternoon, good morning, good evening, depending on where you are here. We're just starting the day here on the west coast of the U.S. I'm in LA, and thanks for that great intro, Milad. Absolutely. Hang on just a minute. Let me fire up my own little 10-minute version. So anyway, can you see my screen?
Yeah, we can see your screen.
All right. Anyway, hey, welcome. Glad you guys are joining us today. It's really a great collaboration and has been. BIMobject and SimScale have been helping each other for a while because we each have different legs of this industry that we're. I won't say disrupting anymore. I'm going to say replacing. I switched my own talk points a while back because disruption. We've been doing this for years, so. I'm going to say that we're replacing it, and I'll jump right into the slides. Give you a little bit about what BIMobject is doing, how we're working to replace it, and the reason I say that it's being replaced is we truly have been for 40 years trying to disrupt this industry, and I say we've rearranged the deck chairs on a Titanic, and as you can see on the screen, there's a little image I have there that I found on the web of the Empire State Building being built, and I'll tell you. When I saw that, I said, what's different here 88 years ago versus today? And largely nothing other than there's not a tower crane. So that being said, that technology in the built environment has really, the disruption has been we're emailing PDF drawings, cut sheets, spec books, instead of delivering rolls of blueprints and paper. But it's still paper-based thinking largely. There are adoptions of technology that's starting to break through, and one of them is the BIMobject and SimScale togetherness, and so we each provide something here. I'm going to talk a little bit more about that, why it's so critical. But we're seeing VDC, IPD, BIM, all these acronyms are coming up, and they really are replacing often what has been historically the linear progression of getting a building built. So we need to leverage digitalization. That's what's going to allow us to replace these processes. What is digitalization? It actually, I looked up on the web a definition, and it's actually, we got to change the business model and have new revenue and value producing opportunities. Again, BIMobject and SimScale together, virtualizing, or what we say in a minute, you'll see digital twin, is creating a whole new value chain, and we're solving problems that many times weren't figured out that they were problems till after the building was occupied. So now with digital content, true digital content, not just geometry, true digital content, we really are starting to create a system of Legos, which you'll see when Milad demonstrates a little later on here, how they've taken the digital content and parts and pieces of a complete system, not generic VAV box, not any generic outlets, but true building product manufacturers, actual content, and again, not just the 3D aspects, but the metadata, the properties that go along with it, the friction coefficients and so forth that you guys use in your day in and day out work needs that needs to be data, not off of a PDF sheet. So I highlighted an area here in the middle that where SimScale and BIMobject really work together, and that's with the architect and engineer. And it doesn't matter if it's a brand new building. This is kind of the area where BIMobject manages a big piece of the ecosystem with our core, which is the content. But what I highlighted here is really the area where we work together very well, and we need each other on it, and creating a really valuable tool set for you guys to utilize. This is just an overview. I mean, just a generic, not generic, but it's a platform view of our content. So again, the only thing we have on the BIMobject product platform is actual building product manufacturers' real data. And again, not just images, not just geometry, it's the values. And we work and I use in a lot of my discussions with these building product manufacturers, SimScale as one of the real validations for them to invest in real, valid, valuable content. It makes a huge difference. Because what we're doing, and I will add too, that there are a number of different authoring platforms for modeling: Revit, ArchiCAD, SketchUp, Vectorworks, AutoCAD, that we actually create plugins for. So designers and engineers don't have to disrupt their workflow. They can, within those environments, actually go out and bring in content right out of our platform. So one thing I say to guys a lot, have you ever been in a building cooled with a generic HVAC system? Well, we all, and I know most of you on this call are probably a little bit laughing here with that concept, but you wouldn't believe how many people don't really get that. So real facilities are being digitally constructed instead of drawn. SimScale is one of the preeminent, as you can even see here. This is a slide out of another presentation I've used in the past, showing one of your CFD simulations. But you got to have the real content, and you got to have the values of the metadata. The engineers don't have time, and not only that, it's an opportunity for error if the content you're putting in has a PDF attached to it that you have to go get all of the values of the properties of that particular VAV or air handler. And so what we like to say is we have real connected data connected to real content. It gives you not just the geometrics, but when you drop I think this is a dishwasher, for instance, drop that into a kitchen. Well, not only do you need to know that it fits or what it looks like, but what's the heat gain when you're developing an HVAC system. So what digital tools allow us to do is they allow us to build it twice. So we're actually constructing that facility in a model before we actually build it in the field. And we're not just constructing it with, again, generic content. It's being built with the real pieces, parts for a complete system. I was vice chair of the market education team a few years ago at the National Institute of Building Sciences here in the U.S., and we developed our National BIM Standard version 3. And one of the things, our team's job, my team's job was help the U.S. Construction industry understand what this BIM thing is. And we saw one of the greatest impediments to actual value-added proposition and implementation of BIM was there was a lack of real digital content. Everything was being modeled with generic. And as you guys know better than anyone, that doesn't really work. So we needed actual building products. That's what actually brought me to BIMobject a couple of years ago. Actually, a number of years ago, I reached out because I saw them as one of the few that were looking to provide digital content in a file agnostic way. At BIMobject, we don't really care what file formats the manufacturers want to use to host it. We look at SimScale and the users to help the manufacturers understand what file formats they should be hosting it in. So we host it in just virtually any type. So that digital twin are real facilities. And as it's designed, procured, assembled, and that's where you guys or the SimScale platform comes in often, in the engineering and design, that ends up what gets procured, what gets assembled, what gets commissioned. Building owners have become aware that they can really leverage even IoT and start attaching that to a digital model. And the real value is in all the properties and the metadata. Is that performing? Is that science lab, the cooling system performing as it was in your CFD simulation at engineering and design? That's able to be vetted. So what is all this about? I mean, in a little bit bigger picture, I say that communication is the foundation of the building industry. And when I say that, it's not just me talking to you or you talking to the engineer talking to the constructor. The whole point is that an owner comes with requirements, and those requirements go to a designer or a VDC, or it doesn't really matter, but someone who decides what to build. The engineers decide exactly what to use to build that. Then the procurement and assembly gets done with a construction manager or a VDC or someone else. That gets turned back over to the owner and meets the requirements that the owner set out in the first place. But what we need for that to happen effectively, which doesn't happen and hasn't historically often enough, is we need an unbroken communication flow. I submit to you, the only unbroken communication flow available to any of us is digital. Digital is not an interpretation. Drawings got to be interpreted. Specifications got to be interpreted. Digital information is ones and zeros, black and white, yes or no. There's no question about it. And by us minimizing this interpretation, we're eliminating opportunities for error and wounds. Because let's face it, we all have a different opinion when something is somewhat unclear, or even one person thinks it's clear, but it's verbally communicated or even communicated on paper. It still has to be interpreted. So a little bit about BIMobject. 97 out of the 100 largest architectural firms in the world are using our cloud. We actually have a little over 900,000 registered architects, engineers, construction managers, facility managers, building owners that are utilizing our site and our content. 95 out of the 100 largest design and engineering firms in the world, which are most of you guys, I believe. You folks would be in this classification. Here's one that really, I think, is telling, and it's getting bigger. 74 out of the 100 largest construction firms in the world are using the cloud. And that tells me that these guys all have to, they've always been the ones that have had to interpret, they always had to make whatever was designed real. They had to create the actual facility. So these are the guys that actually early on found and felt that this digital adoption or this digital toolbox was a fantastic way, a bulletproof way, if you will, to get together what needs to be done and then accomplish it. So with tools like SimScale and BIMobject content living through that full building life cycle, we're able to do things we never even could conceive of before, and do it much more profitably for us, effectively for the owner, and for the world at large. Our CEO is Stefan Larsen. He likened BIMobject to the construction industry's equivalent of Spotify. So it's not about the music, but it's about a platform or a service that gives access to all of the world's information about building components. With 28 million articles of building content on our platform, and having SimScale styled need for real content, it is giving us to change the world. So we're a community for all actors in the industry, all the way across the full building life cycle. So together, BIMobject and SimScale, we're leading the industry. We're providing tools for today's built environment. If any of you are in the States in November, actually be happy for you to stop by and visit with us. We're at Autodesk University, one of the largest gatherings of that is a single software platform, but we do support it very heavily. We're here in Las Vegas, and as well, some of you we may see at our BIMobject Live coming up in October there in Malmo, Sweden. We are a global company. We have offices all over the world and support building product manufacturers and platforms like SimScale, and look forward to continue to help each other grow this environment and what we're doing. So with that, Malid, and unless you have anything else you want me to add, I'll turn it right back to you.
Thank you, Steve, very much for this interesting presentation, also for all the insights you gave us. And can you make me the presenter again?
Absolutely.
Oh, wait one sec. Ah, perfect.
Are you able to grab it now?
Very much. Yes. Oh, wait 1 second.
Pardon us, guys, while we hand off each other from halfway around the world, literally.
Yeah, that's true. All right. Are you able to see my screen now? All right, it seems so. So let's start. Yes, and I would like to continue with the second part of our today's webinar. And as Steve already mentioned, this process of digitalization means that we will be able to test things virtually without the need to build a prototype or something like that. And the next 5 minutes, I'm muted to talk with you about the benefits of using simulation. And first of all, just to make sure everybody is on the same, let's say, basis. What is simulation? Well, simulation is actually used a term to describe methods and tools which allows us to virtually test any kind of products. And whenever we talk about engineering simulation, we are talking about tools which are able to predict the performance of a physical product, which can be, for example, also a building. And to understand what is the great, or why engineering simulation brings such a great potential to the AEC industry, I would like to talk to you about a very interesting real-world example from Germany. And in Aachen, it's a quite small town in Germany. You may never heard about it, but Aachen, they have a university hospital, which is quite famous and also very good. And this hospital, you can see the facade of it on the left side on the slide. And it was designed like 50 years ago and built 45 years ago. And back then, there was no computer or CAD technology, which helped the engineers and architects to design the building. So everything was based, let's say, on, rule of thumb. And what happened in the end of the day is that they finished this hospital building, and after some weeks they found out that something was completely wrong. with the HVAC system because it was much too hot inside the building. And it came out that actually the whole HVAC ducting system was under-designed. So all the ductings were too small. And in the end of the day, the only possibility they had was to build a second ducting system outside of the building, a kind of external ducting system, which you can see right now. And yeah, this was very expensive, as you can imagine. And also in the beginning, a lot of people get upset about it because they said, how is that possible? It looks so super terrible. And as a funny fact, some years ago, they already put it on the monument protection. But I wanted to share the story with you because it really shows what is great about simulation, because it allows us to test things and validate our designs before investing money and time to build them and make them come to life. And actually, simulation is helping us to build better design or to build better products in a shorter time. And it can be applied basically in every industry, but it brings a lot of, let's say, special advantages for the building industry, because in the building industry, usually you don't have a prototype. So you have a very big risk, or the risk is very high that if something is not working, it will really cause a major damage. And when it comes to simulation, there are, let's say, some generic benefits which I would like to discuss with you. So first of all, engineering simulation. Using engineering simulation allows us to test designs and the efficiency of our designs. And actually, there are a lot of different areas of a building project where you can apply simulation. And so using simulation, a very early stage of the design process, really allows us to test different approaches and to go new paths. And I already mentioned that the great thing about simulation is that it doesn't need any physical prototyping. The only thing you need is a CAD model of your design and this is very important, the right data. A lot of times people are only talking about the CAD data and they totally forget that the CAD data is only the half of the description of your model, and the other half is based, let's say, on boundary and initial conditions for which you definitely need data. And for example, when it comes to a ducting system, or let's make the other example, when it comes to a pump, you're usually not only interested in the size of the pump, but also like what is the flow rate which it can release, and what is the energy needed to operate the pump. And this kind of data, it's really crucial, and it's really frightening if you think about it, that we are like living in the 21st century, but people are still using sheets of paper or PDFs to gather around the data they need. But let's come back to simulation. So the great things about simulation at the end of the day is, and we can really minimize, or let's say substitute all the advantages to 3 bullet points. The first one, it helps us to reduce time. It really reduces the time investment we need, because simulation is faster than preparing a physical test. And whenever you save time, or you're saving money, and the other way around. The next thing is that it helps us to minimize the risk of failure. A lot of companies or customers using our tools are actually not really doing any optimization. For them, it's just, let's say, a stage of the product design process, where they want to make sure that everything will work out. And usually these are companies which are offering, let's say, the same products which are a little bit customized to different companies. And for them, it's really crucial to be able to test if the product is still working like it should. And finally, as I mentioned, it allows us to reduce costs, because we can reduce physical prototyping on the one hand, and on the other hand, as it's minimizing failures, this is also reducing the costs. And now I would like to talk with you about how simulation can actually be used in the building industry. And SimScale actually supports 3 major type of simulations. One is structural simulation, the other is fluid flow simulation, and the third one is thermal simulation. And whenever it comes to design equipment, for example, if you're a company which is supplying pumps and fans for HVAC systems, then you can, for example, also use structure simulation to really improve the equipment itself. But usually SimScale or SimScale simulation capabilities, which are used for building industry, are fluid flow simulation. And first of all, it's used to validate HVAC systems and parts. And this is what we also want to do today. So we are gonna to validate what is the airflow inside, for example, a ducting system or through a grill, and how it is interacting with the environment. And based on this, the first thing you can do is to improve the energy efficiency of your building, because you can improve the energy efficiency of the HVAC equipment you're using, or you can choose the right HVAC equipment based on the results of your simulation. Then another big point for CFD is predicting wind loads. This is not necessarily related to HVAC, but more to structural things, and especially to national regulations, because usually from a certain building height, you need to show that the wind loads which are acting on the building will not make it collapse. And for small buildings, you can use some tables, but for larger ones, you need to provide real test results. And usually what people do is running wind tunnel tests with small models, with small scale models, which is super expensive. And using CFD, you can really make a simulation of the full scale model, including the surrounding, and it's much faster, much cheaper. But besides that, CFD is also used a lot for what we call optimized turbo comfort. For example, people are optimizing the locations of pressure in and of air in and outlets to make sure that the comfort for the occupants inside the room is as good as possible. And you can also use simulation to simulate the, let's say, spread of pollutants, or to, let's say, overall analysis about the air quality and contamination. Well, and from what I've told you so far, you must think that simulation is really a great thing, and you must also think that it's the industry standard, but it's actually not. Only 5 out of 100 engineers have access to simulation tools. And back then, like 5 years ago, when we founded SimScale, we were really shocked by these numbers and thought, well, what do we have to do, or what needs to change to make simulation a standard tool which can be used by every engineer, architect, and designer in the world? And back then, we identified 3 major barriers which were stopping engineers from starting to use simulation. And the first one is really associated with the pure cost. Usually, if you want to get started with simulation, this requires an upfront investment. Yes, and this can easily be around 20, 30, or 50,000 euros just for the first year. And really, most of the software tools comes with unbelievable high software costs, which makes it very difficult, especially if you don't know if you're going to use the software every day, 24 hours. The next thing is related to the computing infrastructure you need, and that even if you would have the software for free, you would still need to pay a lot of money for buying the right computer infrastructure, for setting everything up. And usually you need like specialists, which are just working on your computing infrastructure and make sure that the tools are working together and that everyone can access the computational power he needs. And the third reason is that, let's say, traditional simulation tools were made for simulation experts, and it was quite hard for pure designers or planners to get started with them. And our idea was to solve this by establishing the world's first cloud-based simulation platform. And that's what SimScale actually is. With SimScale, the only thing you need to access 3D simulation tools is a working internet connection, a standard web browser. And that's really everything. No installation, no download. You even don't need own computing power, because all the computational power comes from the cloud. And you can access through your web browser a fully fledged 3D simulation environment where you can set up different kinds of simulations, optimize your designs, and share your results with colleagues. And I don't want to talk too much about SimScale, but just to put it into a nutshell and summarize the most important, let's say, USPs of SimScale. So first of all, SimScale is what we call an all-in-one tool. And this is a pretty interesting approach because usually simulation tools come with complex license models where you need to buy a dedicated license for every feature you want to use. So let's say you are doing fluid flow simulation and you want to do additional structural simulation, you need to pay a new license. Let's say you want to run larger simulations and need more computing costs, you need a new license. And this really sucks, guys. And SimScale, we make no difference. You can everyone access the same tools, the same algorithms, independent from if he's a free or a paying user. The next thing about SimScale, which I really love, and I have to say I have like a nearly 15 years background in simulation, and even after years, a lot of times, I was struggling because I had to wait for computing capacity, for having some free computing time on our cluster. And with SimScale, since it's cloud-based, everything is super fast and easy. So your simulation or the computation of the simulation result starts immediately in the cloud. You can choose how many processes you want to use, which will directly influence the time which is needed to calculate the solution. And you can use it from every device around the world, and you actually even don't need to make any thoughts about where to store your data. The next thing, which was very much related to this cloud-based approach, is the real-time support of SimScale. With SimScale and our SimScale user success team, you get instant help via chat, phone, email, and besides support, we also often offer consultancy, free webinars, and trainings. And two other things I would like to raise right now. One is collaboration. So with SimScale, it's super easy to work in international interdisciplinary project teams. As everybody, you can like share your data and stuff like that. But at the same time, SimScale is still super secure. Since we have our own dedicated security team here at SimScale, which is implementing leading edge encryption technologies to make sure that your data are protected. Is protected, even if it's stored in the cloud. All right, and finally, I don't want to talk too much about SimScale. We are not only home in the field of architecture. We are used by a lot of other industries too, like electronic design, automotive, aerospace, or even the valve and healthcare industry. And actually, for every picture you can see on the slide, there is a story where a SimScale customer is using our tools to optimize the product. All right, and after I've talked so much about theory, now let's get our hands a little bit dirty. And as I've mentioned, we have prepared a live demonstration where we have downloaded the geometry and model from BIMobject, grabbed the CAD data as well as other data which are relevant for setting up the simulation. And then we created a simulation of this part and got a lot of more information about its performance. And first of all, by the way, I see we have a lot of questions and we will answer all of them during the Q&A. So first of all, as I mentioned, our aim is to simulate geometries from BIM objects and SimScale. And today we'll take the seat of the HVAC engineer. And let's imagine you're involved in a project which is about finding the right HVAC concept and the right HVAC ducting layout for a residential building. And this time you're thinking about using something from a supplier, and you go on BIMobject because it's a place where you will find all the data and the models from the big and small manufacturers you need. And let's say you say that this model is exactly what you've needed. And what we want to do right now is to perform a simulation, since the manufacturer of this duct system, in this case the company Isover RS, is not providing any information about the flow field generated by this HVAC duct. And let's say you're also thinking about adding specific fans to this duct system. and you want to know how these fans are interacting with this ducting system. Yeah, and let's say this is our ducting system. We're going to use the fan for this, which we also find in BIMobjects. And directly at BIMobjects, we can like access all the data. And one of the data we need is what is the flow rate provided by this fan. And we have the geometry of the ducting system. And now we're going to set up a simulation. And I don't want to go too much into the detail of the simulation. For those of you interested in that, the project is public available, so you can import it yourself with one click to your SimScale workbench. The only thing you need to do for this is to create a free SimScale account. And so we are going to let the fresher stream it into this HVAC ducting here, and then we have different exit locations. We will do a steady state simulation using a K-Omega SST turbulence model, which those of you maybe are familiar with who worked with CFD in the past. And this turbulence model is important to predict the vortex structures the right way. Well, and what are we going to do? So the first step is what we call the CAD import. And for this, in this case, you need to go on the BIMobject website, download the CAD model, and then upload it to SimScale. But in the future, we'll also have a direct connection, direct data exchange, a direct cloud-based data exchange between SimScale and BIMobject. So the first thing you need to do is to upload your CAD model, and then you're going to set up the simulation. And this includes usually two important steps. The first step is what we call meshing. And as you can imagine, the computer is using a discrete model of the flow. So we are just calculating the flow, pressure, and velocity for dedicated regions of the model. And these regions, their size and the density of the regions needs to be defined by the user in advance. Once this is done, we can, and this process itself is called meshing and can take some times because you need to calculate let's say the discretization of the mesh. And the next step is to do the actual simulation setup. So to explain the computer or the platform how your model is interacting with its environment. And finally, we do what we call post-processing. We're going to visualize the simulation results. And yeah, so I have prepared something. So, and this is, as you can see, it's in my web browser. And this is a project I've prepared where you can, let's open this project. It can take up to, I don't know, 30 seconds, 1 minute sometimes. And yeah, now here it is. Here we can see the geometry. We can also like hide faces, take a look inside, do stuff like that. We can group surfaces, rescale it. And as I mentioned, the next step is what we call meshing. And yeah, we have a lot of different what we call mesh operations. So different algorithms which are dividing your model into the cells. And in this case, we use the hex dominant parametrics. There's also an automatic hex dominant mesher. But here we wanted to have some more control over the mesh. And this is how it's looking like in the end. And for every of the center of each of the cells, we are calculating velocity and pressure values. And for sure, you need to make the mesh or to adapt the mesh fineness and make it very fine where you expect to have large gradients and large changes and make it causal where you don't think that we have large gradients. And yeah, we can really see how, for example, in the near of edges, the mesh is refined automatically. And after that, you're going to set up the simulation. And for this, you need to select which mesh you want to simulate. You need to select which material you want to simulate, which fluid substance, in our case, air. And then you just define like which faces are inlet. So this is our inlet with a in volumetric flow rate of 1 cubic meter per second. You define the location of your outlet. Now they are blue, and everything else are walls. Well, and once this is done, you can like adapt the accuracy of your simulation. And for example, the simulation took us 2 hours using like 16 cores. And then you can also take a look at the 3D results for sure once this process is finished. And actually, you can do everything with the web-based post-processor. You can also download the results, but the web-based post-processor is very powerful. For example, one thing we can do is to, for example, work with cutting planes. Visualize different variables like, you know, the velocity or the pressure. It's very straightforward. Yeah. However, so let's get back to the presentation. Yes, and that's what you can do with SimScale. And now I've prepared some slides summarizing the simulation results and showing what we get out of that simulation. So first of all, as I mentioned, simulation provides us with a clear picture about the velocity and pressure distribution inside the ducting system. So this image is showing the pressure distribution outside of the ducting system, and for sure we can also visualize pressure losses everywhere. For example, here we visualize the pressure loss in the Y junction due to flow separation we have here and here. And obviously this shows that there is some potential for optimization, for example, adding a fillet here or something like that. And in this R junction we have this very similar phenomena. For example, again, it's a flow separation. And yeah, we can not only visualize the pressure, but also velocity and other variables help us to understand why the separation is happening. In this case, it's quite obvious because it's much too sharp and you have these edges, and you can also create like really interesting animations showing how the flow is like distributed by the system. And let me make it full screen and let's see if it starts. Yeah. And here you can see like the separations we have here. Yeah, and here you can see again the separation in this joint. Yeah, and it's, as I mentioned, quite powerful and reliable too, from the point of simulation quality. Yeah, and then there's also one thing I would like to discuss with you, and this is basically which methodology is used to predict pressure losses inside HVAC systems. And the big challenge in the past was that simulation was not available, and people needed a way to determine the performance of HVAC systems, which are made out of segments. And one thing you usually do is you use like an analytic model where you're describing every section by section using like a cross section and stuff like that. And usually this is not very precise. We are talking about, yeah, up to 10% difference. And here CFD is able to provide you with a much better idea of the flow values. And you will say maybe, well, 10%, why should I care? Well, a lot of times it's maybe not important, but whenever you have like big changes, for example, pressure separations, this is something which cannot be predicted very well by analytical models. And so CFD is not only adding, let's say, more precision, but also it allows you to understand what is happening inside the flow. And here, for example, another example how you can visualize the flow using streamlines, which are mapped by pressure. Yeah, and can even clip them and change like the legend of visualization. All right, thank you very much for your time. It was a pleasure. And I think there are 2 questions. And if you have more questions, don't be shy. Just submit them through the question toolbox inside of GoToWebinar. And I think the first 2 questions, there's Steve, the guy who should answer them. Steve, are you still here?
Unmuted. Muted. Unmuted.
Yes, yes, sir. Great job, Milad. Absolutely. Yeah, so I was just doing a little bit of homework. Question was about, I guess the one is kind of a statement, but I'm curious if there's other, maybe I'm missing something on it. It says the generic content. Yeah.
Peter wants to know what options are there to minimize the time effort of transitioning these downloaded families to a more usable solution.
Yeah, and I guess I'm needing to understand what are the challenges specifically, and I can speak to what I know from some of our user base, which is not going to be often as sophisticated as what this audience is probably looking for. But that doesn't mean we are addressing it as complex, comprehensive, and sophisticated as humanly possible digitally. One of the challenges we have is, I get it day in and day out, is helping this, a HVAC or a manufacturer of building products understand how his content's being consumed. So as far as BIMobject goes, and there's other content creators as well, often the manufacturers try to push off investing in what the time that's necessary in developing the content beyond just the geometric or visualization, without having all the data parameters involved. So something else that we do at BIMobject is we have a feature called property sets, or BIMobject property sets. We externalize as many of the properties and metadata as possible, so it doesn't. A lot of times, especially visual designers or early design stage designers, they say, "Oh, we don't want all that data in there. It makes it too heavy. The object is too heavy. It loads up my model, and then I got 5,000 of those outlets, and I don't need to know all that information about all those outlets." So we have what's called property sets, which allow that, because there is a call to home function, it allows those properties or that metadata to be downloaded or accessed later in the process when it's appropriate for you guys to need it. That's, I think, the most valuable option is externalizing these properties so that they don't have to track along with the file model. It's more of a threaded instance of real-time values, as opposed to something that's built into a model that's handed off. Because part of the evolution of this whole digitalization of the industry is we got to get to where we have a collaborative environment that people are sharing this model and working on it together, and still being able to access by like a SimScale cloud. But not everybody right now. Too many times it's developed on someone's desktop, and then what do? They hand that file off to somebody else. Well, immediately it's outdated as soon as you start handing files off. So as we get to a data store model of a built, a facility being developed, we'll have less and less problems with that, and things like this externalization of properties will be able to happen much more readily. I hope that answered the question. If not, I'm happy to dig in deeper, or even offline or after the fact. Peter, just feel free to reach out.
Yeah, I think that sounds great. And in the case Peter has some more question, you can just write it down into the chat box or reach out to you by email.
Yes.
Then there is a next question by Alex Lee, and Alex Lee asked how to import Revit models into SimScale, since they are stored in a Revit 5 format. Yeah, that's a good question, Alex. We right now offer different file importing options, including the step file format for data exchange or Autodesk. And in this special case, since the Revit import is not ready now, but it's on the way, guys. So in this case, we open the model ourselves in Revit and saved it as a step file. but actually every, let's say, professional CAD tool can import Revit and output step or another file format. So right now we use the converter, but in the future you can import it directly using SimScale. And just here as a question regarding wind tunnel testing, and he wants to know how expensive they are compared to CFD. And that's also a very good question, Jose. Let me start like this. It's not possible to say in general CFD is costs so much of a wind tunnel test. It really depends on the application. And if we're talking about the building industry, to have a good example, a wind tunnel which is suitable for this kind of application usually costs you, if you rent it, let's say around 10,000, 15,000 euros a day. Plus you need to model. And then it's about the complexity of your building. If it's just like brick, it will be quite cheap. If it's a complex facet, it can be really expensive, as much as a small car. And if you need, and now the big question is, what one do you want to measure? If you don't want to measure forces or some pressure values, it's included in the wind tunnel rent. But if you, let's say, want to measure a lot of pressure taps around the building, if you want to measure the flow field, you need a PIV system. This can end up to like 100,000 euros for the model. And if you want to go with SimScale, it's actually, as I mentioned, for free. So we have the free community plan where you can simulate actually as much as you want for free, but then your simulation results are public. And if you need a private account, it starts like around 2,000. We have a private pricing starting around 2,000 or 3,000 euros a year. And then like a simulation of a wind tunnel test costs you maybe several hundred euros. The simulation I showed you right now, it's also, I don't know, 100 euros, quite cheap. There is no modeling, meshing, and post-processing time charge. The only thing you pay is the core hours you're using. And for example, this wind tunnel is an aerodynamic simulation of a building with 20, 30 million cells, costs you a couple hundred of euros. But this is something which really depends on the application. And there I would reach out if you want to have more information about the application which you're working on. Just reach out to me by email or to my colleagues from sales team, and he will try to assist you. All right, it seems like this were all the questions, and I think we're also ending on time. So Steve, thank you again very much for being with us today. It was a big pleasure to have you as a guest speaker.
Thank you. It was a privilege. I appreciate it. And look forward to any other questions any of you folks have.
Yeah, it seems like all the questions are answered so far, but I think people know our email addresses, so they can reach out directly to you or to me if there is another question raising up.
Fantastic.
And yes, I also want to say thank you to all of the attendees. It was a big pleasure for us, and hope to see you soon again with one of our other webinars, or maybe we'll meet at one of the on a trade show or something like that. However, I wish you all a nice, great rest of the week. Stay tuned and see you soon. Bye.
Bye-bye.